Alright guys, the second portion of your Quadratics workbook is going to be all about real world application of Quadratics. We're going to start kind of simple today, and then next week you'll look all about how things are thrown into the air and what those equations would look like. So starting with this one, the length of a rectangle is 15 meters greater than the width. The area is 126. Find the length and width of the rectangle. They have described my length in terms of my width, so I'm going to say W is my width. And then to figure out my length, I don't want to use a new variable. I'm just going to say it's W and then 15 more, so W plus 15. I'm going to draw it out just to make sure I'm following what it looks like. And I know the area is 126 meters squared. Just like any rectangle, length times width equals my area. And I want to be able to set this equal to 0, so I'm going to distribute my W. So I have W squared plus 15W equals 126. And then I'm going to subtract 126 from both sides. W squared plus 15W minus 126 equals 0. So then from there, I've got to factor. You probably shouldn't have to do the box method or grouping method or anything. I know that W times W have to be my two leading factors because I have one W squared. It's not a leading coefficient of anything other than 1. So I need to find something that multiplies to negative 126 but adds to positive 15, and those are not super close, so my factors are not going to be super close. For me, I just like to use the prime factorization. So you have two options for that. You can do the factor tree, which is, writing 126 and then just breaking it up. 126 is 2 times 63. 63 is not prime. I circled 2 because it is. 63 is 9 times 7. 7 is prime. And 9 is 3 times 3, and those are prime. So to get to 126, as long as I multiply 2, 3, 3, and 7 in some fashion, I'll get 126. One will have to be negative, and then the bigger one will have to be positive, so when I add them, I get 15. So you can really just start however you want. I'm just going to start grouping these two. I have 6 and 21. 6 times 21 I know equals 126 because I used all of my factors, and then if I subtract them, because one's going to have to be negative, I could get 15. I want more positives, so that's going to be my negative. So lucky us, that worked out beautifully for the first guess, even though we did a little bit of legwork to make it easier. So I have minus 6 and plus 21. W equals 6 and W equals negative 21. This doesn't make sense in the context of our problem. We can't have a negative width. So I'm going to leave that out as even an option right now. So the width is 6 meters. Notice I am labeling my answers. And the length is 6 plus 15, which is 21 meters. And I can go back and just multiply those and check to make sure it's 126. Notice this 21 and this 21. Not sure if that's a coincidence or if we'll see that that's always going to be the case. Problem number 2 is find two consecutive positive even integers whose product is 168. So you got to know a lot of vocabulary. Consecutive is following each other. Monday and Tuesday are consecutive days of the week. We all know what positive means, but that might have some help us determine what answers could work and what ones don't. Even, we know, and that's going to help us set up our variables. And integers are whole numbers, positive and negative whole numbers. And then, of course, product is multiply. So if I said, two even integers that follow each other could be 6 and 8. So if I said the first integer is x, normally in consecutive integers, it'd be x and then x plus 1, because consecutive is 1 more. But since we're doing consecutive even, I have 2 more to get to the second even number. So it's x plus 2. And this one's going to follow very similar to the last problem. I have the first integer times the second integer equals 168. I'm going to distribute x squared plus 2x equals 168. And then I want to get it equal to 0, so I'm going to take away 168 from both sides. From here, I have to factor to solve for x. So again, I don't have to do anything too crazy because I know my leading coefficient, my a, is 1. So I can start my double bubble. I know one's going to be positive and one's going to be negative to get the negative 168. So I have to multiply to negative 168 and I have to add to 2. So since my sum is close, it's low, it's a low number, that means my two factors are going to have to be relatively close to one another. So I don't even need to bother guessing numbers that are really far away from one another. But I am going to do what I normally do with big numbers and get my prime factors. 168, and I'm going to do this in my head. 168 is divisible by 2, so that's 84. So I have 2 times 84. So 84 is left. 84 is divisible by 2. It's 2 times 42. 42 is 2 times 21, and 21 is 3 times 7. So from here, you just kind of have to start guessing. You can do 2 times 2 times 2, which is 8. And then 3 times 7, which is 21. And no matter how I do it, whoever's negative, I'm not going to get a positive 2 out of it. So even if I made that a negative, what would that be, 13? So I need them to be closer. So instead of grouping 3 2's, I'm going to maybe just group 2 2's and a 3. So I'm going to do this. 2 times 2 times 3 is 12. And then the leftover 2 and 7, I'm going to put together and get 14. And sure enough, when I subtract those, because I have a negative, I get a 2. I'm going to make the 12 the negative, though, because I want more positives left over. So I have negative 12. I'm going to put it with my minus, and positive 14. So that all equals 0 still, so we're solving. So x equals negative 14, and x equals 12. Positive integers, so x can't be negative 14. So our first integer is 12, and then x plus 2 equals 14. So my two integers are 12 and 14. The last problem, the dimensions of a garden are 6 feet by 12 feet. So I'm going to go ahead and draw my picture. And they are each increased by the same amount in order to enlarge the area. The new area is 208 square feet more than the original. What are the new dimensions? So I'm going to use x. It's not going to stand for a side. In this case, x is going to stand for the increase. I'm going to redraw it. So I know I did 6 plus x, and then I'm going to do 12 plus x. I know the new area is 208 feet more than, so unfortunately I need to figure out what was the old area. They didn't give that to me explicitly, but we can figure it out just by multiplying. So I have 72 plus 208, so I have 280 feet squared. Length times width to find the area of any rectangle, and that had to equal 280. And then I'm going to do the FOIL method, or the distributive, double distributive. So I'm going to do my first term. 6 times 12 is 72. 6 times x is 6x. X times 12 is 12x. And x times x is x squared. And I'm just going to take a few minutes to clean it up. I'm going to make my x squared term first. That combines to 18x. And to be able to solve my quadratics, I'm going to minus the 280 from both sides. So I have x squared plus 18x minus 208 equals 0. And then I got to go through the process again. What multiplies to negative 208 but adds to 18. 208 divided by 2 is 104. So 104 is 2 times 52. 52 is 2 times 26, and then 26 is 2 times 13. My numbers have to be fairly far apart because 18 is a pretty big difference in the two numbers. So I'm just going to start here. 2 times 2 times 2 times 2 is 16 times 13. And 1 will have to be negative. I have to get to a negative, so if I want positive, I'll make the smaller number. So that's 3. Nope. I need to be further apart. So I'm going to give one of the 2's to the 13 and see what happens. 2 times 2 times 2 is 8. 2 times 13 is 26. I know that multiplies to 208. I'm going to put the negative with a small number. 26 minus 8, 18. So my solutions are x equals 8 and x equals negative 26. Obviously negative 26 can't be an increase. So remember, x equals 8 feet is just the increase. So let's make sure we're answering the question they want. Did they ask for that, or did they ask for the new dimensions? So the new dimensions would be 6 plus 8 and 12 plus 8. So my new dimensions are 14 feet by 20 feet. And you're done.